Moonpig.
Hi, everyone, and welcome to the Moonpig Tech Podcast. I'm your host, Sam Cox, and with me is my co host.
Hi, I'm Richard.
And with me today is our guest, Alexis, who's going to be talking all about application architecture.
Hello there.
So, if you could just introduce yourself first, Alexis, what's your role at Moonpig and what's kind of been your career progression?
So I'm a principal engineer at Moonpig. I cover what we call the enablement space. So that's our platform teams and developer experience teams. I started my career in cybersecurity, remained in cybersecurity for several years, and then moved into full-time engineering in the last 3 years.
Okay, thanks for that. So, we're going to be talking about application architecture today, and specifically the kind of architecture that the Moonpigs kind of built over the past few years. A typical term that we hear about this kind of architecture is a term called event-driven architecture. Could you maybe talk to us about that a little bit? What is an event in this kind of context?
So an event is anything a system produces. So it could be either a message telling the world that it's done something. For example, an order has been made or a user has been created. But it also can be a command. So it could be something like create a user or create an order. And normally events are listened to by other systems, and those systems will do something with it. So in the case of create a user, the other system might go and create a user. The system ends up producing several events, and you'll find them usually on something like a queue or bus or event bus.
Okay, so we've got an idea of what an event is. How do we build a system that makes use of those events?
So there's a lot of options around this. We at Moonpig use AWS primarily to build all of our infrastructure. And so in AWS, there's EventBridge and SQS and SNS, and we leverage all three of those when it comes to building these systems. We also use DynamoDB as our main storage for data, and that also can generate event streams.
Okay, and once you've built a system to respond to those events, what does that system give you in terms of advantages? What does that offer you?
So when you talk about how systems communicate between each other, you can think of two types of communication. One would be synchronous and the other would be asynchronous. Events fall within the asynchronous bucket. And what it means is things are no longer waiting on other processes to finish or happen. So for example, if I make a request in a synchronous matter, I need to wait for the entire service and the whole workload to finish before I can release that resource and move on to my next task. In asynchronous messaging, what it allows me to do is provide the task to the service that I want to execute that task, and the service will go off and do that, and I can go and do something else in the meantime. And then once that task is finished, I'll hopefully receive an event myself saying, hey, that task is done, go and do something with it. That leads to things like higher performance. So when we think about asynchronous in even the smallest of worlds, like not even in large systems, like within programming, your program might be more performant, might be able to multi-thread its workloads. The other thing is in large systems, you can queue up those events, and so it allows you to deal with bursts of traffic or bursts of workload.
So if we've got data flowing through our system in the form of events or commands, or maybe we just use the term messages for now, what does that mean for state? How's state managed within your system?
So state becomes pretty difficult to manage in the event-driven architecture because each system receives its state at different points in time. You can't guarantee when they will receive it. So you you run into what we call eventual consistency. So eventually your data will be consistent across all systems, but it won't start there. This means that you need to build with that in mind, and you need to build around that. So for example, if I was making a system that allowed me to view if a product is in stock, when I go and ask is this product in stock? What I might be getting back might not be the exact truth at that point in time. And so if I'm going to build a system that allows me to purchase that product, that system needs to have rules or ways of dealing with the fact that the product might not be in stock at that point in time. There's loads of ways of doing this. One would be you tell your customer that sadly the product wasn't in stock, even though they saw it in stock. Another way would be you build a buffer of stock so that you can deal with that eventual consistency coming into play.
Okay, and so when you're managing that state across different services and you have this eventual consistency creep in, how do you deal with different services managing that data?
Yeah, so at Moonpig, we build localized projections of data. So, for example, if I've got a orders system and a gallery system, they both need to know about products, but they won't actually use the same data source for the products. And the way you achieve this is you would have a third system, which would be your product space, and it would emit events saying a product's been created, a product's been updated, a product's been deleted, your usual CRUD events. And the local data projections will receive those events and create a local version of a database that is up to date based on those events. This means that your teams can build those two individual services completely separately. They don't need to worry about contention in terms of resources. They don't need to worry about the shape of the data. They can shape the data any way they want once it arrives. And it allows for that really nice decoupling between those services and leads to better microservices.
Okay, so you've spoken a bit there about loose coupling, and loose coupling tends to emerge from this approach. Can you speak to us a bit more about the resiliency you get from that?
Yeah, so because we don't have synchronous calls between our services there, so I was referring to the orders service and the gallery service. It means that you don't need to have that synchronous call between the orders system to go and fetch a product from a local data the database that it might be in contention with the gallery. And so you won't run into this problem of, let's say the product database is down and now your galleries don't work or your orders don't work. And so you've basically killed two services, and probably both services were critical. But if you build it in such a way that it's loosely coupled using data projections, the database for products could go down. No one would care because you would still have your local version. And the same for between the two services, they're no longer contending for resources. So it's not because loads of people are suddenly arriving on your website and viewing your gallery that you no longer take orders because the database resources aren't available. So it builds that nice resiliency. The other thing that happens is events are usually idempotent. So when an action happens from an event, you want to make sure that it always has the same result, always has the same outcome, regardless of the state of the data. And what this then allows you to do is replay events when things fail. So for example, if my service receives one of these events and my database was down during that period of time, or there was a hiccup in network, I can put that event into a dead letter queue, so I didn't process it properly, and then replay that dead letter queue to process that event and make sure that I'm in the correct state. So again, with the eventual consistency here, we eventually are consistent regardless of our failure states.
Yeah, gotcha. So I guess another advantage might be that you've got a defined contract between the services emitting the events and the services consuming those events. And I guess that must give some advantages in terms of the way you develop your software as well.
Yeah, so you can create strong schemas and contracts between your services. That's probably the hardest part of the whole event-driven system, because unlike when you're doing synchronous calls where both your recipient of the call and the creator of the call, or the requester, both are like directly involved in the communication, where they can say, "Oh, my schema doesn't match what you've just asked," or here's the data and your schema doesn't match." In event-driven, architecture that does happen after the fact, after you've sent the event. And so it does become something slightly more difficult to manage, but there's plenty of tools out there that let you create your schemas and then generate off those schemas your types for your type-safe programs. And you can then enforce your types and enforce your contracts between your two services. And that's something that can become very powerful, but you do need to build that in.
Okay, and so one of the interesting characteristics that we see emerge out of these event-driven systems is out-of-order message delivery. So you mentioned kind of replaying messages that had failed if there was a hiccup and things like that. And one of the things that these kind of messaging systems results in is that out-of-order message delivery. Can you speak to us a little bit about that and how you kind of compensate for it?
Yeah, so like you said, nearly all messaging frameworks aren't capable of delivering events in order. It's just part of their nature, and so you can't deliver. You can't guarantee the order. You cannot also can't guarantee the number of times they'll be delivered. So they might be delivered 3-4 times. It's just due to the nature of how these systems work. And so, like I said, you need to think about each event you receive and make sure that the actions it triggers are idempotent. So the actions that get triggered off those events happen in an idempotent way. Another reason why this happens is because you might be building a new data projection, right? So you might be building a new gallery, and your products database has all the products that are required for your new gallery, but the database for your new gallery might be empty. And so one of the things people might do is run what we call a full replay or historical replay of the entirety of the events ever created by the products database. And this sort of leads to this interesting problem of that all the other systems listening to those events will see exactly the same events they might have seen, and sometimes, several years old events if your products don't change very often, for example. And so you need to build in that idempotency into all your operations, but also potentially support versions of the schema if your events don't get updated. And all of those kind of problems can show up. So you have to be building your software with that in mind. There's a few interesting ways of doing replays. So we use EventBridge, for example, and EventBridge has got a archive replay button that you can just press, and it replays the entire archive from a certain point in time. There's also a few other interesting methods which can allow you to not need to replay the entire universe. So, for example, if your database stores the state of the object and you wanted that object to be replayed in a sense to hit the new service, what you could do is make a no-op update, for example, to that product, to that object. And then that will cause the events to be fired saying, hey, there's a new product here, or hey, there's an update to this product, and your systems might be receiving that. And so it's sort of I don't want to call it a poor man's replay, but a maybe less intensive replay that you can achieve there.
Well, thanks for that, Alexis. If we've got any listeners who are interested in sort of exploring event-driven architecture, do you have any tips or tricks that you can offer?
Yeah, so I'd start by looking at what is EDA by AWS. It's on the, I think if you just search what is EDA AWS, you'll find documentation there. They cover all of these topics in great detail, especially on how to deploy on AWS. There's also a well-architected document around EDA and what tools, what systems to use, and etc. It doesn't need to be AWS. You can achieve all of these things without any of their tooling. Another thing I'd recommend is having a look at some of the talks out there around EDA. There's quite a few of them. There's one that I went to recently by Ryan Cormack called From Events to Event Driven, which is on the Go to London conference. There's also plenty of talks from the AWS Summit London, which cover event-driven architecture.
Thanks for speaking to us about that, Alexis, and thanks everyone for listening. We'll see you next time on the Moonpig Tech Podcast.